Chapter 8, Performance and Algorithm Efficiency. Algorithm efficiency, best, worst, and average cases. Measuring efficiency and the big O notation. Asymptotic analysis, how to calculate complexities. Orders of common functions. O1. Graphic comparison, evaluating runtime complexity. Summary, Chapter 9, choosing the perfect algorithm. Uniform resource locator shortener. Problems with long URL. URL shortener solution approach. URL shortener swift implementation. Method 1, searching for the correct tuple. Method 2, accessing the correct array positioned by index. Searching in a huge amount of data. The huge blacklist problem. The huge blacklist solution approach. The huge blacklist swift implementation. Method 2, the Bloomfield solution. Summary, epilogue, index. Preface, this book, etc. What this book covers, etc. What this book covers. Chapter 1, Walking Across the Playground, contains the introduction to data structures and algorithms, the Swift REPL, and how to add the Swift statements into it to produce results on the fly. Chapter 2, Working with commonly used data structures, covers classes and structures, the implementation of details for the array, dictionary, and set collection types, how Swift interoperates with Objective-C and the C system libraries, and protocol-oriented programming introduction. Chapter 3, Standing on the Shoulders of Giants, covers how to conform to Swift protocols, how to implement the stack and queue structure, and implement several types so you can achieve experience for choosing the right type based on the requirements of your application. Chapter 4, Sorting Algorithms, covers algorithms, sorting algorithms, and how to apply them using an array data structure. Explore different algorithms that use comparison sorting and look at both simple sorting and divide and conquer strategies. Chapter 5, Seeing the forest through the tree, explains the tree data structure, including a definition and its properties. An overview of different types of trees, such as the binary tree, binary search trees, BST, B trees, and splice trees, with implementation details. Chapter 6, Advanced Researching Methods, covers more advanced tree structures, red-black trees, AVL trees, tree trees, radix trees, and covers several substring search algorithms. Chapter 7, Graph Algorithms, explains graph theory and data structures for graph, as well as depth-first search, breadth-first search, spanning tree, shortest path, and swift graph. Chapter 8, Performance and Algorithm Efficiency, shows you algorithm efficiency and how to measure it. Big O notation, orders of common functions, and evaluating runtime complexity. Chapter 9, Choosing the perfect algorithm, learning how to deal with problems that require algorithms and data structures about creating a high-level solution. Writing the implementation in Swift, calculating big O complexities of our solution to check if the algorithm behaves properly in a real-world situation. Measuring and detecting bottlenecks and modifying the solution to achieve better performance. What you need for this book. The basic requirements for this book are as follows. Xcode, at least version 8.1. Mac OS Sierra 10.12 or OS 10 E El Capitan 10.11.5 or later. What this book is for. Swift data structures and algorithms is intended for developers who want to learn how to implement and use common data structures and algorithms natively. Whether you are a self-taught developer without a formal technical background or you have a degree in computer science, this book will provide with the knowledge you need to develop advanced data structures and algorithms in Swift using the latest language features. An emphasis is placed on resource usage to ensure the code will run on a range of platforms from mobile to server. A previous background in an object-oriented language is helpful, but not required, as each concept starts with the basic introductory conventions. In this book you will find a number of text styles that distinguish between different kinds of information. Here are some examples of these styles and an explanation of their meaning. Code words in text, database, table names, folder names, file extensions, path names, dummy URLs, user input, and Twitter handles are shown as follows. The unit word portion of the name is removed from the method name. A block of code is set as follows. Any command line input or output is written as follows. New terms and important words are shown in bold. Words that you see on the screen, for example, the menus or dialog boxes, appear in the text like this. In Xcode, go to File, New, Playground, and call it B05101-_6 red black 3. Warnings or important notes appear in the box like this. Tips and tricks appear like this. Reader feedback. Feedback from our readers is always welcome. Customer support. Downloading the example code. 1. Walking across the playground. Swift is a powerful new programming language from Apple for macOS, iOS, watchOS, and tvOS. It has been rapidly climbing in popularity since its release at Apple's WWDC 2014, and within a year already broke through as one of the top 20 languages, placing at number 18, based on GitHub usage, http://github.info/ and Stack Overflow discussions. In this book, we are going to look at the core data, structures, and algorithms provided in the Swift standards library. We will also look at native Swift implementations for other commonly used data structures and algorithms, such as queues, stacks, lists, and hash tables. Like sorting. Preface, Chapter 1, Walking Across the Playground. What is the importance of data structures? Data structures and plus algorithms as programs, interactive playgrounds, the Swift REPL, fundamental data structures, contiguous data structures, arrays, declaring an array, retrieving elements, adding elements, removing elements, linked data structures, singly linked lists, overview of data structures, overview of algorithms, data types in Swift, value types and reference types, named and compound types, type aliases, collection types in the Swift standard library, asymptotic analysis, order of growth. Summary. Chapter 2, Working with commonly used data structures. Using the Swift standard library, wire structures, declaring arrays in Swift, initializing array, adding and updating elements in array, retrieving and removing elements from an array, retrieving and initializing dictionaries, initializing a dictionary, adding, modifying, removing a key value pair, retrieving values from a dictionary, declaring sets, initializing a set, modifying and retrieving elements of a set operations, comparison operations, membership and equality operations, characteristics of tuples, unnamed tuples, named tuples, implementing subscripting, subscript syntax, subscript options, understanding mutability and immutability, mutability of collections, interoperability between Swift and Objective-C, initialization, Swift type compatibility, bridging collection classes, and as array to array, and as set to set, and as dictionary to dictionary. Swift protocol-oriented programming, dispatching, protocol syntax, protocols as types, protocol extensions, examining protocols for use in collections, array literal syntax, making an array enumerable, sequence iterator protocol. Summary, Chapter 3, Standing on the Shoulders of Giants, iterators, sequences, and collections, iterators, sequences, collections, stack, applications, implementation, protocols, queue, applications, implementation, protocols, circular buffer, applications, implementation, protocols, priority queue, applications, implementations, protocols, stack list, applications, implementation, protocols. Summary, Chapter 4, Sorting Algorithms, the insertion sort, the algorithm, analysis of the insertion sort, use cases of the insertion sort, optimizations, merge sort, the algorithm for array-based merge sort, analysis of merge sort, the algorithm and analysis for linked list-based merge sort. Performance comparison, quicksort, the algorithm, cost implementation, analysis of cost partitioning scheme. The algorithm, cost implementation, analysis of cost partitioning scheme. Choice of codes. The wrong way, first or last element. The wrong way, select random element. The right way. Improved pivot selection for quick sort algorithm. Optimizations. Summary. Chapter 5. Seeing the forest through the tree. 3. Definition of properties. Overview of different types of tree. Binary tree. Binary search tree. B tree. Splay tree. Red-black tree. Binary trees. Types and variations. Code. Binary search trees. Insertion a node. Inserting a node. Tree walks. Traversals. In-order tree walk. Pre-order tree walk. Post-order tree walk. Searching. Deletion. B trees. Splay trees. Splay operation. Simple rotation or zigzag. Or zig or zigzag. Zigzag. Summary. Chapter 6. Advanced searching methods. Red-black trees. Red-black tree node implementation. Rotations. Right rotation, left rotation. Insertion. AVL trees. AVL tree node implementation. AVL tree rotations. Simple rotation left. Simple rotation right. Double rotation right left. Double rotation left right. Search. Insertion. Tree. Radix. Tree. Look at several substring search algorithms. Substring search algorithm examples. Naive brute force algorithm. The code scope algorithm. Summary. Chapter 7. Graph algorithms. Graph theory. Types of graphs. Undirected graph. Directed graph. Weighted graph. Graph representations. Object-oriented approach. Structured classes. Adjacency list. Adjacency matrix. Incidence matrix. Data structures. Vertex. Edge. Adjacency list. Depth first search. Breadth first search. Spanning tree. Minimum spanning tree. Prim algorithm. Short path. Dijkstra algorithm. Swift graph. Summary. Chapter 8. Performance and algorithm efficiency. Algorithm efficiency.